Last student's missing. So OAB is sector of a circle, center O radius 6. The area of the sector is 35. Calculate the perimeter. What would be your idea? I don't want to know the answer to it. Just give me the first part of the question. How would you break this question down to work out the answer? Go.
You try to get the angle.
That sounds like a good idea. You're gonna work at the angle first. Give me a second. Where are we? Which page are we on? There we are. Let's put a page in here. Okay. Give me a second. Where's my page on? So let's cut this question out and have a go at this question. This is a calculator question. So yeah, go on. So for this particular question first, they're giving us the area. So when they mention the word area, what are you thinking about when it says area of a sector? So how would you work out? So what is the area of the sector?
It's pi times diameter, but you do like times the angle over 360.
So the area is equal to normally pi r squared. That's the area of a full circle.
Oh yeah.
Yeah, remember it's the area of the full circle. Now, because we only got a part of the circle, we've got only this part of the circle, the angle theta, which is now, how would we then work out the fraction? What would theta be as a fraction of the circle?
It would just be that over 360.
Correct. That would be that over 360. Absolutely correct. So over 360. So we got the area of the full circle, and this is the fraction of the circle that we're dealing with. And they gave us the answer for the area. What was the answer for the area? What was it?
35.
35. So where does 35 go? In that calculation, in that formula we've just written down, where would 35 go?
It's the area, so it goes on the other side.
Goes right at the beginning.
Yeah.
And we have pi times the radius. Do we know what the radius is?
Yeah, it's 6.
So the radius is 6 squared. Do we know what the angle is? No.
No.
So we know everything apart from the angle, which we can highlight over here. We don't know the angle. The angle's over here. This is the angle. So we don't know. So in order for us to go and work at the perimeter of the sector, we need to first of all work at the angle in the question, which we haven't been given, but we have to go backwards and work it out. So how would you go from your formula that you have here, which you gave me correctly? Okay, how would you go from that? We got the values put in there now. How do you work out the highlighted theta?
You have to rearrange the equation.
Sounds like a good idea. Sounds like a plan to me. Go on then. So when we rearrange the equation, we have a technique called start, identify, actions, and reverse. So when you start at the theta, we have to identify what's actually happening. Which is the first action that theta has been acted on by?
Divided by 360.
Fantastic. And what's the second action has been acted on by?
Multiplied by pi r squared.
Lovely. That's so you've identified first, second action, which I'll label as first and second. And now in order for us to make theta the subject, I need to move the actions in the reverse order to what you've identified them to. So which one should we move first?
Pi r squared.
Lovely. So opposite timesing is?
Divide it.
Which is on the bottom, and opposite dividing on the bottom is what on the top? Timesing. Okay, so if I was to rewrite it now more clearly, so we can have 36 pi, whoops, no, not 36 pi, we'll have 360 times by 35 divided by 36 pi is equal to theta. Is that correct?
Yeah.
Okay. So, Bilkis, get your calculator out, please, as well. Right, let's grab our calculator. Okay, here's our calculator. Here we go. Rightio. Okay, so we get the fraction button ready. Everybody at home, get that ready. So 360 times by 35 divided by 36. I hope you're all doing this right now in the calculator. Essen, I want you to answer in the chat now, just to make sure that you're awake and you haven't gone to sleep at home. So I know you like going to sleep. No, don't tell me. He can hear you. Don't tell me yet. Let's see what he answer he gives me. We're checking his whether he's awake or not. Right, everybody answers please quickly in the chat, including you, Arva. Oh, Essen's got a nice answer, quite big. Essen, now you have to think about your answer and think, does that answer look round about right? I mean, they've given us a small slice of pizza and you got the full pizza nearly. Okay, Abdullah's answer matches Arva's answer, matches Inaya's answer, but Essen's answer is on the moon, where he is eating cheese. Okay, don't forget to put the pie in there. Go back, put the pie in. And tell me what you got. Okay. Okay, Bilkis, how much show me answer? 1,099. Whoa! Bilkis has gone to the moon as well. Allahu Akbar. Okay, lovely. So back to you, Arwa. Right. So the theta is equal to what? 111.
111.5.
0.408460. Now, remember one thing, because this calculation is needed to work out the main calculation, one thing that you must not do here at all, you must remember no rounding here, because this is an answer, it's an interim answer, it's in between one calculation and another calculation. You are not allowed to round it off. They haven't asked you for the angle, you need the angle. So the answer that you have on the calculator, you can see on the screen, is the calculation that you're going to reuse that exact value in the next calculation without any rounding. So do not write over here 111.4 and use 1.111.4. So do not do this and do not use that number. That number will give you rounding errors and can cause your answer to go away from the correct answer to a kind of extent that you will actually lose the mark. You'll be too far out. So it's important that we use the exact value. In this particular value, it wouldn't make too much of a difference if you were to leave 111.4, because the rest of it is quite small, 0.8. But just for generally speaking, especially if that was, for example, that was an 8, that would make a more bigger difference. Okay, so we're gonna leave the calculator answer where it is. I'm gonna move the calculator out of the way, and I'm gonna let you finish up the calculation. So, okay, so you worked out the angle for me, which we're not gonna round, which we're not allowed to round, because we're gonna avoid errors. It's a calculate the perimeter. So we've done part 1. So here comes part 2. So part 1, we worked out the angle, and the angle is here. There's the angle. So in order for us to work out the perimeter, what do we need to work out first? So look at the top pizza slice, which is over here. Okay, somebody fell out. Look at the top pizza slice, which is there, and tell me, break the perimeter down into pieces for me in chunks.
The perimeter is pi times diameter, or pi times 2r,
Okay, right.
and then times by
So slow down there, Kaka. What I mean is this. I want you to break the perimeter down into its components, the orange components and the green components. So
so it's like a part of this.
It would be the radius. Add the radius. Add the arc length, yeah? Yeah. That partial circumference, the green bit. So I'm now going to color code it for you. So my perimeter and our perimeter is going to be the green bit plus the 2 orange bits. Is that okay?
Yeah.
So that's called our idea. So let's start putting some numbers into it for me. So the R is equal to
6.
And the other R is equal to
6.
And now the arc length. Now, the arc length we haven't worked it out yet. The arc length we haven't worked it out. How would you work it out?
Pi times 2r times by the angle over 360.
Fantastic. 2 pi r is the circumference of a full circle. The theta over 360 is that proportion of that fraction of the circle that we are, which is in the above pizza slice, I call it. Yeah, we only got theta amount of the full circle. So let's start putting some numbers in. Okay, so we have 6 at 6 is 12. So the radius is equal to 6. 2 times by 6 is 12. Then we have another 12 pi. Now the theta angle will be 111.408 blah 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 divided by 360. So this is the part that we have to be clever in the exam paper, that we are going to be reusing our, okay, right, here's our calculator. Here's our calculator. Now, remember, when you finish that calculation, don't get excited, start pressing on. Do not press on, do not delete that memory. So we're now I'm going to do this calculation. Everybody's doing it with me now. Do this calculation on your calculator. Follow me, please. So we're going to start with, so I'm going to start with straight away 12. Add 12 pi. Okay, no, that's not add. Oops, times. So it's going to be, this bit here is 12. 6 add 6 is 12. Then 12 pi times by all of this. So fraction button. Now remember, so Arwa, this value here using my calculator, I can't see anymore. Where's it gone?
You have to press the answer button.
Fantastic. The answer button automatically stores the last answer that was on the calculator that disappeared when I started doing new calculation. So I press answer, the calculator will fetch that number for me and use it. Okay, so lovely. From the top, I need to press replay, bring it to the bottom. 360. Okay, now everybody check my calculation on the screen. Is the calculation correct? Have I written it properly? Bilkis. No, look at my calculation, not your calculation, look at mine. Look at that calculation. Does it match the calculation? Does this match that? Yeah. Okay, everybody do that on your calculators, and I need an answer back from each person. Okay, Inaya's already given me her answer. Excellent. Okay, I think it's my Wi-Fi. I'll try to get back in. Yeah. Okay, Asin's been kicked out. Okay, everybody press your equal button and send me the answer. I'm not pressing equal yet. Okay, Mr. Abdul Hamid, wakey, wakey, young man. Let's get cracking. So we have Abdul Hamid. We have Abdullah. What's happened to the other Abdullah? Okay, we have Arwa and Inaya. Okay, right. I'm looking for answers. I've got 2 answers. Abdul Hamid, I need an answer from you. Okay, so far, Inaya, your answer is matching. Abdullah's answer is good. I need an answer from Arwa. Yeah, your answer is matching theirs as well. And everybody's got direct message, so you can't copy each other, which is good. Abdul Hamid, wakey, wakey, young man. Calculator. Right, okay, let's share the answer. Press equal. I got 71 over 3. What do I press now, Bilkis? SD. Okay, that gives us 23.6 recurring. 23.6 recurring. Okay, and it goes, it wants it to 3 significant figures. So that means we're going to have loads of 6s basically. That's what recurring means. So back to you, Arwa. So Arwa, how would I do that to 3SF now? So the answer, I'm happy with the answer. What does it mean 3SF?
Just the first 3 numbers.
So 1, 2, 3, and then what do we do? What do we look at next?
The next number, and then you round it.
So the next number, because it's 5 or more, we add 1 to the 6. So what's the final answer?
23.7.
And then what happens to all of these numbers? What do you do them?
You just
cut
don't
them off.
them.
Yeah. Okay, lovely. So the perimeter, because the perimeter is a length and everything is in centimeters, what should be the units here?
Centimeters.
Fantastic. Now, this is an exam style question, actually from an exam paper. So that just shows you how you were to do the questions. Alhamdulillah, you've done it very nicely. You had the right idea at the beginning. You wanted to work out the missing angle. From the missing angle, you were able to work out the arc length. From the arc length, you added up the radius twice and you worked it out. And we didn't do any rounding on the first part, and we recycled the question by using the answer button on the bottom of the calculator, which stores the last answer free of charge for us. Okay, so this is the kind of stuff we were doing last week. I will just a quick recap. Where else were we? Okay, so after doing those questions there and all of the variations of that, we moved on to cylinders. So working out the volume of the cylinders, nice and straightforward, nothing really difficult there. Working out reverse volume questions where they give you the volume, you've got to work out the height. Again, no problem really. The next part actually was calculating total surface areas of cylinders. Okay, now that was done in a particular way. Now I want to move that out of the way and let's see who can remember that for fresh. Okay, right. Okay, thank you for that, Aura. Appreciate that. Very nice participation there. Okay. All right, let's just quickly copy the 4 and the 8. The 4 and 8. Okay. Okay, right, we'll use that. We're just gonna, this is our revision. Right, so home students. Mr. Abdul Hamid is not giving any transmission through the chat of anything, whether he's awake, he's living, he's animate, not animate. What's going on, Mr. Abdul Hamid? We're not getting any input from the chat of any answers. I know you just came, but you came and you joined the question at the right time. So I gave you calculation, and you haven't responded. Okay. That's not really good enough. You just came. You came before the beginning of the question. And I told everybody, use the calculator and work it out. And you're not responding. You're not taking part in the question. Okay, right. Let's find somebody who's living. Okay, Abdul Hamid is probably just waking up from his sleepy. Right, let's have from Inaya, please, with the I. Join me. Let me move my calculator out of the way. And let's quickly recap how we work out the total surface area of this cylinder. Oh, this is cylinder. Okay, so we are doing some more revision. So the total surface area of this question.
So first you have to work out the area of the circles.
Okay, lovely. So you're giving me the idea now. So the total surface area, how many circles do we have?
2.
Okay, which ones are they?
The top one and the bottom one.
Fantastic. So you have 2 circles. I like to draw my 2 circles. Okay, so we have a 4 radius there, 4 there, lovely. So we're gonna what's the formula for the area of a circle?
Pi r squared.
Yes, what is it?
Pi r squared.
Okay, no, you.
Oh.
Salia, I'm in the lesson, Salia. Okay, so pi r squared plus pi r squared. Now, what did we do last week to the actual this curved surface area? What did we do to it? We had to. What did we do to the cylinder? We had to cut the cylinder and pull it apart. Now, when you cut the cylinder, the curvy bit, and we pull it apart, what shape do we get? What shape do we get?
Oh, a rectangle.
And what's the width of the rectangle? It's called the height of the cylinder. And what's the length of the rectangle? Now remember, the length of the rectangle is the distance around this circle. What do we call that?
Wait.
Okay, look at the diagram. I've highlighted for you on the diagram. The orange distance around the circle will be the length when we cut it open and flatten it. So what is that measurement called?
The arc length.
That's not called the arc length. That's called the Bilkis. The orange bit. Wakey, the orange bit. The orange bit's called the area around the outer side of the circle. The circumference. Mashallah, she finally woke up. So circumference, which is equal to 2 pi r. Okay, so the orange bit. So I'll highlight it, I'll color code it. So the orange bit is orange bit. The green bit is this bit here, which is here, the height. So I'm color coding from there. Lovely. So how would you work out the area of that rectangle with those measurements? Back to you, Naya.
2 pi r h.
Lovely. 2 pi r time by h. Length, our length time by our width. Fantastic. So what do we do now?
2 times pi times 4 times 8.
So pi time by 4 squared plus pi time by 4 squared plus 2 time by pi time by the radius is 4 and the height is 8. Is that right?
Yeah.
And the rest of it is calculator work. Or if you want to simplify it, that'll give you 16 pi. Add 16 pi. And then we have 2 times by 4 is 8. 8 times by 8 is
64.
So 16 pi at 16 pi is 32 pi. 32 pi at 64 pi is
96 pi.
Allahu Akbar. This girl, she's working in a pie shop, apple pie shop. Okay, 96 pi centimeters squared. Now, if that was to be given as the answer, they ask you the answer in its pi format, then you finished. Okay, and that I call the answer the pure answer. Pure answer means there's no information that's been lost. Everything is contained in there. You won't get a more accurate answer. Right now, everybody grab your calculators, including Mr. Abdul Hamid. Wakey, wakey, Mr. Abdul Hamid. I want your answer first. 96. Type it in, young man. Shift pi. I'm not pressing equal until I get answers on the chat. Go. Everybody in the class. We need to be awake. Okay, so I've got an answer of the Okay, Abdul Hamid's answer is matching. Everybody's answers will be matching. Good. Let's check it. Press equal. 96 pi. Okay, right. So we have an answer of. Oh, can you hear that? Thunder? Christmas. What's Christmas got to do with you? Are you listening? We can hear the storm outside. It's like thundering. And Bilkis was his Christmas. Listen, Bilkis, Father Christmas is not coming down on his reindeer, you know. Oh my days, Bilkis, which world are you living in, Bill? Oh my days. Okay, blah, 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 blah. Okay, so everybody, I want you to give me an answer for that to 1 dp in the chat, everybody at home. Quickly. So the total surface area equals to 1 decimal place. Everybody give me an answer at home. Arvaz was the first one to give me an answer at home. Arvaz, your answer is very good. Nobody can copy you. Let's see what their answer is. What's your answer? Allahu Akbar. Oh, okay, good. 301.6 centimeters squared to 1 decimal place. Boom, boom. Okay, excellent. So, Inaya, what is the key part of any question that we do in an examination scenario? What is the key thing that we need to do? What is that part called? What's that part called, Inaya?
Do you have to round it up? Round it to 3, I don't know.
I've highlighted it for you.
Round it to 1 decimal place.
What is the key thing when we do any exam question? I hope I'm still sharing the screen with you, because I'm highlighting the answer. I've made it bigger And you're still not giving me the answer. What is the key thing when you got to work out the question? Can you see the shared screen, Naya?
Yeah, but I don't know what that means.
No, read it.
Idea.
Allahu Akbar. Oh my God, this girl doesn't know what the idea is. She gives me the idea, she doesn't know what she's doing. Oh, what can I say? What is happening to the students of the world today? The idea is the part that you told me in the beginning. That's the most important part of any question that you do, is knowing how to break the question down and what the question entails. Then the formulas come on the next time. Then the values go in, then the simplification, then the answer, then the rounding. So everything comes step by step. Now that's the most important thing, having the right idea. You gave me the right idea. You said it's going to be the circles, then add the curvy bit. The curvy bit is this, and the height is this. And that's how we work it out. And back onto where we're supposed to be for today. Ooh, question number 13. Okay, where are we? Right, let me find that question. Okay, I think we're here. Let me add a page. Okay, here comes our next question. Copy. And paste. What? A what? Come on, get them in the lesson. Idiots. Okay, right, question number 13. Okay, here's a hemisphere of a radius 8. Calculate the volume, the area, the total surface area. Okay, let's have a look at these questions. Right, let's have Abdullah. We only have one Abdullah this week. I wonder what happened to other Abdullah. Abdullah.
Okay.
Abdullah, so read the question for me read up to A yourself.
Here is a hemisphere of radius 8 centimeters. Calculate the volume of the hemisphere.
Okay, so okay, right, let's have a look. Let's go back up here. So do we have any new formulas? So should we just quickly cut on, let's cut this formula out. I like this formula here. Oops, copy. Oh, flashing stuff. Okay, so we have some formulas here. Goes calculate the volume of the hemisphere. So Abdullah, so when this is hemisphere, I can see the word sphere in there. What does the hemi mean?
It's half a sphere.
Half a sphere, thank you. So for question 13A, everybody get your calculators ready. So the volume of the sphere is 4/3 times by pi times by r cubed. What would be the easiest way to adjust this formula to take in consideration that we only got now half a sphere? What would be the easiest way for us to manipulate the formula? Can you give it to us in the most simplest way, please?
Divide it all by 2.
Divide it all by 2, which is the same as timesing it by
A half.
a half. Okay, so that is the volume of a sphere. And when we multiply it by a half, we are working at a hemisphere. Lovely, jubbly. Okay, let's go. So it's a 4/3 times by pi times by, what's the radius?
8 centimeters.
So it'll be 8 cubed, and then we can time that by half. And because it's a calculator question, you don't need to worry about that. We just throw it all in the calculator, grab the calculator. Okay, everybody get your calculators, put this in your calculation and put the answers in to the chat straight away. Everybody at home. Blah, blah, blah. Let's go. So we have 4/3. Okay, time, whoops, no, bring it back up. Time by shift pi, time by 8 cubed, time by, and then I'm going to write as 0.5 to make it easy for myself. Okay, everybody write that down for me, please. Give me a second, I just got to quickly give them something. What's that bag on? Okay, right. So we got some answers coming through on the chat. Right, I'm gonna press equal now. Whoa, 1024 over 3 pi. And then I'm gonna press the Bilkis button, SD button. 1072.330292. And it goes give answers to 2 decimal places. Bilkis, finish this one off for me, please. 2DP. 0.33. Yeah. And what's the units for the centimeters? Centimeters cubed. Well done. Excellente. Okay, lovely. 13A done. Fantastic. So remember, the main part of the formula is the volume of a sphere. That's the full sphere. Now, because we only got half a sphere, the hemisphere, we have to do the adjustment in pink, the highlighted time by a half, which means we only want half of that volume, which we've done carefully, and we've got a pure answer, we've got a rounded off answer, all lovely jubbly, bubbly, bubbly. Okay, right. Question B, back to you, Arwa. Okay, B. To be or not to be, Arwa? Are you ready, girl?
Yeah.
Okay, good. She says, I'm born ready. Okay. So you the one you work at the area of the curved surface. Now the area of the curved surface has been given to us on this page. I'll highlight it for you in green. What's the area of the curved surface?
4 pi r squared, and then you have to divide it by 2.
Okay, so the area of the curved surface area is equal to 4 pi r squared. That's for the full ball. Because we're going to do half of it, we have to divide it by 2. And that's, oops, sorry, I've got the calculator in the way. Let's go the way. Okay, lovely, let's go. That's it. The curved surface area. Fantastic. Okay, Arva, can you give me some values, please? 4 times pi times by
8 squared, which is
by
6
8 squared divided by
divided by 2.
2. And the 2 will cancel anyway. That's 1, that's 2. So we'll be left with 2 times by 64, which is, what's 2 times by 64?
128.
Okay, so I already got myself a curved surface area for the hemisphere of 128 pi centimeters squared. We've got to give that to 2 decimal places. Everybody grab your calculators and type into the chat what the answer to that is. So 128 shift pi. Okay, let's get some answers back from you guys. Okay. I've got some answers back already. Good. Okay, so that gives you 128 pi, obviously. And then you press SD. And we've got to give 2 decimal places. Okay, let's get back to black. So we got 402.1238597. And now I'm going to write off 2 decimal places. 1, 2. I'm going to look at the 3. So 40. Okay, to 402 to the 2 decimal places. 0.12 centimeters squared. Lovely. Okay, good stuff. It's total surface area. Now, total surface area, normally in the exam, they won't see what they're doing here. They're really helping us by giving you all the information. They won't give you this information in the exam. They'll just say you work this out. Total surface area. So, all right, let's go to okay. Let's go to Madam Inaya. Madam Inaya. So give me the idea, Inaya, for the total surface area of the shape. Can you hear me, Inaya?
Yeah.
Go on.
4 pi r squared.
Okay, right. The total surface area is equal to, give me an idea, meaning it's going to work out we're going to work out the area of the circle,
Yeah,
and then we're going to add the
the curved part.
curved surface area. Is that right?
Yeah.
And that'll give the total surface area. So have you worked out this area of the circle so far?
Yeah.
No, we haven't done that yet.
Oh.
So the area of the circle is going to be, let's have a look, that's 8. That's 8. So that'll be pi r squared, which we haven't worked out. What about the curved surface area? Have you worked that out?
Yeah.
We have. Okay. Okay, now, this is the important part. I'm going to ask you now. I'm going to give you a choice. Are you going to use this? Are you going to use this? Or are you going to use this? You got 3 possible values to put into the CSA. They've already been worked out. The brown, the blue, and the green answers are ready to go, but one of them is the correct ready to go one. So I want everybody in the chat to put down which of those ones I should use, the brown answer, the blue answer, purple answer, or the green answer, because I'm going to be reusing the CSA for 13C. Which one shall I put in? Brown, blue, green. Okay. Okay, good, Abdullah Hamid Naya. Excellent. Okay, lovely. Everybody's saying brown. Fantastic. I love that. Okay, let's get the brown answer then. The brown answer is 128 pi, because we've already worked it out. We don't need to work it out again. Okay, back to you, Naya. Can you help me with the first part to work out the surface, so the area of the circle? Let's finish off.
You do
Pi times by?
pi times by 8 squared.
Pi times by 8 squared plus 128 pi. So you have 64 pi plus 128 pi. What's 64 pi? Oops, sorry. What's 64 pi add 128 pi?
192 pi.
192 pi. Lovely. And then now we're going to, everybody in the calculator, please quickly give me your conversion of 192 to an answer which is 2dp. 192 shift pi equal, no, I'm not pressing equal yet. Okay, Mr. Abdullah, just type in the text. What happened? Why are you joining so late? I text you that, then you joined in. What happened? Where were you? Just text it to me. Okay, right. I'm looking for answers, I've got some answers, lovely answers. Okay. Equal. SD. Okay, dookie. So I'm gonna write down the answer 603 point. What answer we got? One. Okay, Abdullah, your answer is one bit, one number out. Arwa, your answer is good. Inaya, your answer is good. Abdul Hamid, your answer is not so good. If you have a look at my answer, 603.185, 603.19, not 29. Maybe you've done a typo. Centimeter squared, 2 decimal places, boom, boom. We've done the question. Okay, so that one question there had multiple parts. We had a volume of a half a sphere. We had area of the curved bit, which was half a sphere again. Then we had the total surface area, which was using previous question and a new one. Fantastic. Right, let's add to the page. Okay, now here comes the exam style questions now. So what I would like you guys to do, I'm going to do the same questions. I'm going to work them out as a worked exam, and you guys are going to have a go at them first yourselves. So we have ready for you students, lovely students, question number 14 and question number 17. I want everybody in the class to do those 2 questions. I'm going to give you so many minutes, and then I'm going to work off camera on the same answers. Then we're going to share the answers and go through the methods, and just to make sure everybody got it right. What page is it? It's in your sheets. Have you got your sheets? Yeah, those sheets there. It's in there. Okay, so I'm actually gonna load up for you now the original book with that page because I'm actually gonna be working on this. So I need some space, need to use it. So while you guys are going with this, okay, Dr. Lim will calculate that away. Get started, please, on those questions. I'm gonna put a timer on for you guys. But please, we found it. Starting now, go. Questions. Mhm. So I'm actually flicking to the book now. So here we go. That's the book. Okay, everybody at home, can you see that? Can you see those questions still? Can you see them? Okay, lovely. So everybody, please have a go. Question number 14, question number 17. The 10-minute time is already on. While you guys do it, I'll be doing it as well. I'll be doing the iPad, and then we will compare notes. We'll see how close we were. Right, let me have a go. Let me have a go. Okay, this should be fun. All right, so you guys can't see what I'm doing, hopefully. So I'm doing it. If anybody finishes beforehand, there's other questions on the page to do. Hmm. 6 marker. Remember to get your idea right, Bilkis. Yeah? So you need to draw little kind of sketches of what you're going to be doing. If you got your idea right, you're sorted. Good. Okay, 3SF. You don't know what the volume of cylinder is? Oh, you don't know what the volume of cylinder is, Bilkis? Seriously. Volume of the cylinder is equal to the area of the circle part time by the height. Isn't it pi r squared h by any chance? Hello? Hello, look over here. Look here. For you on the screen.
Okay.
Oh my days. Come on, Bilkis. Don't tell me you forgot that. Oh my days. Back to the question. Back to the question. Emergency's over. Emergency's over. Mhm. Where's the timer gone? Sorry about that. I had to have a little sneak preview of the answers. That was nice. Very satisfying. Hopefully nobody saw it. Okay. Okay, the timer's up. Okay, is anybody still working on question number 17 yet? Arwa, have you started number 17 yet? Okay, start number 17, please. As soon as you finish number 14, you need to move on to number 17. Okay, answers for reference for number 14. For those of you actually doing the question right now, just so you have some kind of reference, you should have two answers for number 14. 1050 and 550. 1050 and 550. 1050 and 550. That's for your reference only. Check that, tick it, and move on to the next question. If you haven't got it, I'll go through with you. I've got those values. Everybody start question number 17. The timer's already on. Yes, obviously, Abdullah, you're gonna finish up one question before you start on. Sorry, I didn't look at your message earlier. Finish both questions? Please, well done. Send them away, show me. Yeah, bring it here. Don't say out loud. No, don't say out loud. Bring it here. Don't say out loud. They'll hear you. All right, 1, 2, 3, yourself. I'm just going to quickly jump into the question and check my answer. I've got it to match. Give me a second. Yeah. Woo! Okie dokie. Yeah. Okay, everybody else, I've just finished. Okay, you guys got still 2.5 minutes. Come on in, Nicholas. Come in. Come here. Don't feel shy. Show me your work. That's how look what Pindras you've been doing. Come on, Sanya. Sanya, let's have a look. Yeah, look, you look at my working out now. Because they can't see it, you can see it. Okay, so what I done first of all was look at the volume. Okay, I'm just gonna mute them for a second. So I can speak to you. Okay, so what I'm going to do, folks, I've got both answers verified, checked, all full working out done on my side to share with you guys. Just check Bilquis's, and some bits are good and other bits are need sorting out big time. So what we're going to do now, we're going to have our normal 10-minute break now, and that gives anybody any extra few minutes they need to do some more work to kind of polish it off to get those 5, 6, 11 marks. So we're just gonna have a break now, and then after the break, then we will reveal all in terms of all the answers and stuff. Okay, surface area, somebody send me surface area. Okay, otherwise your answer is incorrect for your surface area. It is literally half the size. It's gonna be like literally nearly double. You've missed something out. Don't forget, Arva, when you're doing the surface area, you have got the area of the curvy bit, which is a quarter of that. And then this is half a circle, that's another half circle. Then you got the area of a full circle as well to add on to it. Oops, I'm kind of giving you guys the idea. Okie dokie. Right, 10-minute break starting from now. Where's my timer gone? Break time. Wee. think those comments were numbered. Right, okie dokie. Right, so let's get back to these questions. Lovely, lovely, lovely. Okay, let's give you some answers first of all. Obviously, they don't give you working out. Question number 14, 1050 and 550. And them are the pure answers, 1000 over 3 pi, 175 pi, right? So everybody, can you just quickly indicate in the chat, out of those first two questions, how many of those you got right? So everybody quickly in the chat indicate out of that two-parter, how many parts they got right. Abdullah B saying none. Okay, at least he's honest. Okie dokie. Whoa, another one, none. And the other Abdullah, two right. MashaAllah. Okay. So, okay, Abdullah, you got one of them right. Good. Okay, Bilqis, how many got right? Have those two? The first one? Alhamdulillah, you got one right. Okay. And back to you. Oh, you got B right. Okie dokie. Right. Let's close this down. Go to this one. Show. Right. So number 17 has one answer. Right. Can you please indicate in the chat which one, how many of you got number 17 right? Okay. Arwa, and you? And now you got right. Whoa. Okay, Koki. Shaking it up. Okay, Bilqis, and you? Oh my guys. What's wrong with you, girl? Okay, I think now is the moment of truth. We need to do some revealing of the answers and the techniques and the technologies. Oops. Okay. What's happening here? I think it's frozen out. Okay, right. Right, let's get back to this. Sorry about that. Things have been a little bit of, I think it's been frozen in time. Give me a second. Let me just try to do that again. Some slight technical difficulty there. Give me a second while we try to relocate. Oh, no, there's not. Screen mirroring. Yeah. Okay, right. Let's try again. Let's try that again. Okay, question number 14. Right, which person's feeling brave and wants to join me on explaining the methodology of these questions? Or do you want me to explain those? Okay. Let's Abdullah, the one who got them all right. Up you go. Question number 14. Give us the idea for question number 14, part A. Go, go, go.
So for this one, you find the volume of the hemisphere at the top, and then you find the volume of the cylinder at the bottom and add them.
Okay, so is this your idea, which is on the screen?
Yeah.
So you work at the volume of the cylinder plus the volume of the hemisphere. That's how he's going to work out the total volume. Okay, that's a lovely idea. Good stuff. The formulas are there above. Okay, what was the next layer of working out that we done?
You
What's the volume of a cylinder?
It's 2 pi r squared plus 2 pi r h.
Okay, volume of the cylinder, isn't it going to be, oops, wrong color. Isn't it going to be pi r squared, the area of this cross section times by the height for the volume?
Oh yeah, I was looking at the wrong question.
You're looking at the wrong question. Okay, organize this out, man. Okay, next. So that's the volume of the cylinder. What's the volume of the hemisphere?
So it'd be 4 over 3 pi r cubed, and then times it by half.
Adjustment?
It's halved because it's half a sphere.
Lovely. So we have to multiply, we have to adjust the formula by multiplying by half because we only have half a sphere. It's called a hemisphere. So our idea becomes formulas. And then what do we do with the formulas on the third line? What do we substitute in?
The radius and the height.
Okay, the radius is equal to 5 and the height is equal to
10.
10. And where do we get those from? Here and here. This is the radius, this is the height. And you put them into the right place. So the height goes in here, the radius goes in here, the radius goes in here. So then you multiply it all out, add it all up. And what's the pure answer in red?
1000 over 3 pi.
And then when we turn that into a SD, what do we get?
1047.2, which is 1 dp.
Okay, now remember in this particular question, they wanted to create SF. So that's important. So my decimal value answer is this. This is my calculator answer. Okay, so I try to put as many digits as I could. And they want the answer given to how many significant figures?
3.
3. So starting from the first non-zero digit, which is 1. So that's 3 significant figures. We have to look at the 7. The 7 is telling us to add 1 to the 4. That becomes 5. 105. And then we're finishing the number 1 digit before decimal point. So we've got to fill that digit space with a what?
It's 0.
With a 0. And then after the decimal point, the rest of that gets truncated, gets choppy, gets chopped off, gone. So 1047.19755, 2, 3 significant figures is 1050. Right, if you haven't got that correct working out done, can you please get it down now in your notes? I'll give you a few moments to copy it up, and then I'm going to move on. So as soon as you finish copying that, getting that all down there. So remember, the first part is the idea. Then the next layer is the formulae. Ooh. And the next layer is the substitution. Okay, and then we have here is our pure answer. And then we have our calculator S to D answer. And then we have our rounded answer. Okay, so these are the layers of the work that you're going to be expected to do in the examination on your own. Yeah, idea, formulation, putting the formulas into the idea, putting the values into the formulas, getting the pure answer, pressing the SD and writing the whole answer, then rounding it off, and then you finish with the prize. 1050 is the prize. Yeah. Okay, Arva, did you get this first question right? A? Can you hear me, Arva? Okay, lovely. Okay, question B, Abdullah's going to do first, and we're going to get somebody else to do the next question. So question B says, calculate the surface area of the paperweight. Okay, I think I should have really choppy that part of the question out. Give me a second. Copy. Paste. So calculate the surface area of the paperweight, give your answer correct to 3 significant figures. Okay, Abdullah, I'm hide my work right now. Back to the original question, Abdullah. So you got both of them right now. Arwa, did you get the second one right?
Yeah.
Okay, the second one's yours. Thank you for that, Mr. Abdullah. I really appreciate your part A. Part B, go, Arwa. It says calculate the surface area of the paperweight. Give your answer correct to 3 significant figures. Can you verbalize your idea to me, please?
Calculate the surface area of the dome, and then calculate the surface area of the cylinder.
Okay, now when you say the cylinder, there's multi-components of the cylinder. Can you be more specific?
Like the rectangle part when you open it up, and then the circle at the bottom.
Beautiful. That's what I wanted to hear. So, what? Okay, I don't want to show you too much of that. So you said you got to work out the area of the domey bit, which I've drawn. You got to work out the area of the rectangular bit, which you told me about that I've drawn, and the area of the bottom part. So the dome, the sides, the bottom, done. What's the next thing that we do after you have the idea?
You put in values.
You put in the formulas, not the values, put the formulas in. So the total, the curved surface area of the dome is 4 pi r squared, but how much of the dome do we have?
Half.
So I time by half. And then the area of the rectangle is going to be length times by which is 2 pi r times by?
Right.
Lovely. And what's the area of the bottom base of the shape?
Pi r squared.
Fantastic, lovely. Now, if you go back to the diagram, what's the radius?
5.
Okay, and what's the height?
10.
Okay, so those numbers should be popping up in here now. So let me see where those numbers pop up. I'm trying to do them in different color. So we have the 5 coming in here, the 5 coming in here, and also even the 10 coming in here, and the 5, there you go. There's those values coming in. Lovely. So when you put those values in and then we start canceling and simplifying, so what is the pure answer?
175 pi.
And then what is the calculator SD answer?
549.7787.
Lovely. And then the last but not least, what is the rounded off answer? The rounded to 3SF answer is equal to, what is it?
550 centimeters squared.
Okay, lovely. Total surface area is that. Okay, folks, right. So feast your eyes on that. So let's get back to this. This first part is called the idea. Then we put the layer of formulas. And then we put in the substitution. Then we start to calculate and, in this case, simplify the answer. And then we get the pure answer. Then we get the calculator answer, which is the press the SD button, the full answer. And then we get then we round it off. And when you round up to the CSF, we have to stop at the 9, look at the 7. 7 saying add 1 to the 9, the 549 becomes 515. You stop at the decimal point, and then you truncate all that. That gets all chippy choppy off. Okay, lovely. Right. Has everybody got that now? Arwa, did you get this one right?
Yeah.
Fantastic. Okay, so we got 2-parter done.
So,
Yes.
for the idea,
Yeah.
the third one, the third drawing, like,
The
why
circle.
do you need it? Yeah, the circle.
Yeah, what about it?
Like, why do you need to include it?
Okay, let's look back at the shape. In this shape, it's solid glass paperweight. Does the paperweight have a bottom?
Yeah.
Well, that's why it's included.
Oh, okay.
Yeah, just because you can't see it in the 3D view, it's actually there.
Yeah.
If I was to draw it for you, it would look like this. Give me a second.
Yeah. Oh, I forgot about that.
Yeah. Okay, right. Who got question number 17 right? Put your hand up. Who got number 7? I think it was Inaya. Inaya, did you get number 17 right? Inaya, question number 17. Inaya, are you there? Hello? Sir calling Inaya. Sir calling Inaya. Have you gone to sleep? Okay, Inaya's not responding. Okay, who got number 17 right? Okay. Oh, okay. Looks like nobody's responding. Right. Question number 17, I'm going to go through myself. It looks like I don't have anybody to respond. Inaya, can you please respond, please? The last thing, not me. Okay, question number 17. Shape S is 1/4 of a solid sphere, center O. Okay, right. I think we need somebody confident to try this question. Arwa, join me on this question, please.
Okay.
Read the question.
Shape S is 1/4 of a solid sphere center O. The volume of S is 243 pi centimeters cubed. Find the surface area of S and give your answer to 3 significant figures.
Okay, so in this particular question, what is the obvious thing that they've left out?
The radius.
The radius. And what is the radius going to be? It's going to give us, is that important that we work it out?
Yeah, because you need it to work out the rest.
Lovely. So in this particular instance, so when we start the question, so the volume of the sphere is 243 pi. So we know the volume, say, what's not a sphere, volume of the, what do we call a quarter of a sphere? It's like a, we have a hemisphere. It's a hemisphere. Okay, if there's ever a word for that, I'm gonna have to find that out. Okay, so how much of the sphere do we have at the moment? Or how much of the sphere do we have?
A quarter.
A quarter. And what's the formula for the normal full sphere?
4/3 times pi times r squared.
R cubed, yeah?
Yeah,
Now,
cube.
what do we do now to adjust that formula to make it quarter? What adjustment did I do?
You can rearrange it so that r is on its own.
That's the next step. What adjustment did I do?
Oh, times it by a quarter.
Because the formula here, this is the full formula, the full sphere, and this one here gives you how much of a sphere?
1/4.
Lovely. And what is the volume of this shape? What is it? Did they give it to us?
243 pi.
Lovely. Now, out of all the things that we have there, which is the only thing that we don't know?
The radius.
So what did we do here? We cancel 4, cancel the 4. Opposite divide by 3 is time by 3. Opposite time by pi is divide by pi. So we do a master's like tidying up, simplifying, rearranging. We do some more simplifying. And the last but not least, what did I move over last?
The cube.
The cube become a cube root. And the cube root of 729 is 9. So we worked out the radius first by using the information of the volume of that shape to rearrange it, reverse the question, work out the radius. So now that we have the key, we can go and work out the surface area. Now the surface area, if you look at the green part of the shape on the over here, Arwa, the green part, how much of a circle is the green part? How much of a circle is it?
Half.
It's half. And the brown shaded part, how much of a circle is that?
Half.
Half. What's half and a half?
Full.
Full. There you go. Half, half, full. Okay, lovely. So let's get rid of all this. Okay. So we're going to work out the area of the green part and the brown part. Green and brown makes a full circle, which is over here. And then we're going to work out the blue part. Now, we're not doing the green and the red part, brown part again. That's just for demonstration from that diagram to that diagram. So the second part, just the blue bit only. The blue bit is 4 pi r squared. Okay, which is the curved surface area. Now, how much of the curved surface area do we have in this particular? How much do we have of the curved surface area of the whole sphere?
1/4.
1/4. So that's my adjustment. Okay, so now this is our idea. This is our formulae. This is our substitution. This is our development of our pure answer. And then we have the calculator answer. And then we have our rounded answer. So once we know that we're working at the area of a circle, pi r squared, done, comes down here. The curved surface area of the sphere, adjusted for quarter of it, by times it by quarter, put in all the values. The radius is 9 from there, put 9 in there. So the 9 actually went in, the 9 went in, everything else was already there. We multiplied it all out, we simplified it all, 81 pi plus 81 pi, 162 pi. We've done the calculator, I've done the simplifying, and finished. So how are you feeling about that question, Alva? Are you happy with that question?
Yeah, I just forgot. I didn't do the pi, so then I did it without the pi in it.
Okay, right. Now, What would you say is one of the most important parts of any question that we're doing today? What's the most important bit?
The idea.
The idea. So the idea here, I've actually drawn it, then I've changed it into symbols, into formula. Always write down your idea. You need to tell yourself, first of all, forget about telling me or the examiner. Tell yourself, what are you working with? I have a half a circle, another half a circle, full circle. I have a sphere, I have quarter of a sphere, hemisphere of a sphere that gives you that shape. So you have to write down all these bits and do all those stages in order to get the 5 marks that it deserves. Okay, without any further delay, we need to move on. I don't want to spend many more weeks on this now. We are now going to move on to this one here, pyramids and cones, and we're going to do this quickly. Right, does everybody know how to work out the area of a triangle? Right, in your chat, type in the formula for area of a triangle. Go, everybody. Use symbols if you have to. Okay, type in the area of a triangle in your chat. Go, go, go. Okay, Arva, good. Arva, good. Abdullah, good. Yes, yes, yes. Okay. Okay, Mr. Where's it gone? Abdul Hamid, are you still there? Okay, who else joined us? Abdul Hamid is here. 1, 2. Okay, we have the other Abdullah joined us. Abdullah. Okay, yes. Okay, right, lovely. Okay, good stuff. Right. Right, so if you want to work out surface area, what else do we have? Are we in the book or are we on my sheet? Are we in the book? Okay. Right, let's cut this question out. Let's dive into the topic with the exam question. Good style. That was a question and a half. That was solid. Ooh, okay, we had a page here. Okay, I think here you're looking. Yeah, that's volume. Yeah. Paste. Okay, let's have Abdullah B. Are you ready to do this question? Quickly
Yes.
with us. Ready?
Yeah.
Okay, lovely. Read the question. Go, young man.
Here is a solid square-based pyramid A, B, C, D, E. The base of the pyramid is a square of side 5 centimeter. The height of the pyramid is 6 centimeter. M is the midpoint of BC and EM, which equals 6.5 centimeter. Work out the total surface area of the pyramid.
Okay, lovely. So this question is to do with what?
The surface area.
The total surface area. Now, so break the question down for me. So if you broke the pyramid down into its components, which components would you have? So do we have a base by any chance?
Yeah.
Okay,
Base.
you seem to be not sure. You have a base. What's the dimension of the base?
5 centimeter.
5 by 5.
5.
So you're gonna have that area to work out.
Yeah.
And then you're gonna have what?
4 triangles.
Allahu Akbar. Now you're talking maths. You're gonna have 4 triangles. Fantastic. Okay, 4 triangles, and give me a second. Let me see if I can do this one again, but get all nice straight lines. That's better. That looks sunny. Oh, okay. Now, so if you're gonna work, how many of those do you have?
4.
4 of them. Excellent. So you have area of triangle times by 4. Right. What's the bottom measurement of the triangle, the base?
5 centimeter.
And what is the height of your triangle?
6 centimeter. No, 6.5.
6.5. Remember, 6 is the height of the pyramid, not the measurement.
Yeah.
Look on the diagram. Okay, lovely. So you give me a nice idea. I like the idea. Let's go. Let's put the formula on. What's the formula for the area of the base?
5 times 5.
Yeah, length times by width.
times
And
width.
what's the formula for the area of a triangle?
Base times height divided by 2
And then times it by?
times by 4.
Sorted. Lovely. Now let's put some numbers in there. What's the base and the width of the so what's the length and the width of the base?
5 centimeters. So 5 times 5.
And the base and the height of the triangle?
6.5 times 5 divided by 2.
Yeah, in any order, doesn't matter. Lovely. So that'll give you 25. And that will give you 10 times by 60, that's 65. And what's the answer to that?
90.
If anybody spots a mistake, please tell me straight away. Okay, length times by width 5 times by 5, base times by 5 times by 6.5. 4 of those. That counts as 1, so that's 2. 2 times 5 is 10. 10 times 6 is 65. Blah, 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 blah. Sorted. Nice, straightforward.
Only times it by 2.
I've already done the time by 2.
Alright.
2 times by 5 is 10. 10 times by 6.5 is 65. All right, so we could double check that in 1 second. All right, let's double check that. Okay, let's close that and let's go to that. And did we get 90?
Yeah.
We did.
Yeah.
Fantastic, bomb blasting. Very good. Oh yes, excellent. Okay, right now. Okay, everybody, now get this down, please. All right, let's get another. Let's add a page here. Key point. We copy. Okay, folks, everybody copy that diagram. Write down the key point volume of pyramid equals a third times by the area of the base times by the vertical height. That's the general formula for a pyramid. Well, this pyramid is in the shape of a cone. We can have a square base pyramid that'll cover it as well. Ooh, my neck is hurting. Okay, everybody copy that down. Formula, you need to memorize it. When you finish, okay, Abdullah B, are we okay with that?
Yeah.
Lovely and yummy.
So when they put equals 1/3 pi r squared h, is that for the volume of pyramid or volume of cone or both?
See, the volume of a pyramid is 1/3 times by the area of the base times the vertical height. The volume of the cone is identical, just that the area of the base is different. In a cone, the area is a circular area, pi r squared. And in the pyramid that we done earlier, it will be a square base. So that'll be length times by width. So it has the same basic construction, but slightly different workings add for the areas because the physical areas are different shapes, but it has the same formula.
Yeah, okay.
Oh. Okay, the pyramid has a square base of side 8 centimeters and a vertical height of 10. So now let's use the formula. Abdullah, stay there with me. And let's use the formula. The top one and the middle one are identical. So if I come over here, this one here, Abdullah, for the pyramid, and this one for the cone are identical in terms of the formulation. I'm going to copy the top one. I'm going to cut the top one out. I'm going to grab that one, copy. I'm going to bring it down to here and throw it over here. So now what's the area of the base? What shape is their base?
It's a square.
It's a square. And a square, the base is length times by?
Width.
No, length times by width. So it'll be a third times by length times by width times by the height.
Yeah.
So do you see here that pi r squared, because pi r squared comes from the circle. You see we have length times by width because it comes from the square. You see the difference?
Yeah.
It's
I
the
see.
same basic formula, but in the cone, the base is a circle, and in the square base pyramid, the base is a square. So
Yeah.
the formula, the original formula is the same. We're working on the area of the base. So let's smack in some numbers now. So there's 8 times by 8. And the height is 10. So what's 8 times by 8?
64.
64 times by 10.
640.
And 640 divided by 3. Does that work exactly or not, or what?
No, it comes into a fraction.
It doesn't matter. Let's work it out then. Let's get the calculator and smash it up.
It's 21.3 be occurring.
So 640 divided by 3 equals, well, that's the pure answer. So that will give us 213.33333 all the way till forever. And the one is to 3SF. So 3SF will be what?
213.0.
No, you don't put 0.0. If you put 0.0, the answer will be wrong.
Oh,
Please don't put 0.0 because you must stop at the third significant figure. You can't go forward unless you got to fill in zeros up to the decimal point. But you never go beyond the decimal point unless the SF is on that side. Okay?
okay.
So that's it. So here's a very basic formula on using that. Okay? And then the questions get much more tricky. Not tricky, then they become let's have a look.
Challenging.
Let's move the calculator out of the way. What else do we have here? What else do we have here? Ooh, the surface area. Okay, everybody, please quickly copy down this formula, please. Key point, the curved surface area. Now, the curved surface area of the cone is this area here of the curvy bit. That's the curved surface area. The CSA, curved surface area, pi RL. Remember that. Pi times by the radius times by the L, where L is the slanting height, slant height. If you don't know that, you got to work it out. The total surface area is going to be what? It's going to be all the curvy bits plus the base. So it'll be pi RL plus pi R squared. Sorted? Okay, question number 9. Everybody have a go. Question number 9 and question number 10. Okay, everybody have a go. Question number 9, number 10. I'm gonna copy it out. I'm gonna okay, I'll get you back to the original book. Here's number 9, number 10s, yeah. I'll put number 9 up for you. I'll full page it. Okay. While you guys are doing the question number 9, moving on to number 10, I'll be doing it privately on my iPad without you guys looking at it. Okay. Wee. After you finish number 9, you should be starting number 10. Come on, folks, we've got a few minutes left. Okay, try number 10 now, please. Assalamu alaikum. Okay, folks, time for the big review. It's time to go to answer mode. Hopefully you guys are finished. We are literally running out of time. Okay. Question number 9. Okay, Arwa, can you explain question number 9 for us, please? Come in.
Should I just say how I got it?
Read from the screen. It should be same as yours. The area of the base is?
Pi r squared. So
Lovely.
it's just
That's right. Same here. I got the same area. And then what do you do with what's the radius?
5.
And what's the answer in terms of pi?
25 pi.
Okay, lovely. What's the area of the curved surface area?
Pi r times the
Slanting length.
yeah.
And what's the pi area?
Is it 65?
Fantastic. So what's the total surface area?
If you just add them together.
Just
So
add the, yeah, that's right. You add the bottom part, the base part, and that part that gives you the total surface area. So you got 25 pi, add 65 pi, that gives us how much pi?
90 pi.
So you can say apple pie then. So get hungry, get the cream out. Okay, question number 9 is done. Well done. Thank you for that. Question number 10. So how do we show that the slant height is 97? What technique do we use? What rule do we use? Arwa?
I did Pythagoras.
Pythagoras theorem. So we have to do, what's Pythagoras theorem?
A squared plus b squared equals c squared.
So 4 squared plus 9 squared equals root 97, is that right?
Yeah.
It's how it works, lovely. Next, the curved surface area is equal to, what's the formula again? Pi r L, that's my L by the way, it's not E, L. So we use the L from the top and we put in the bottom and we get, what answer do you get?
123.76.
So which person's got the more accurate answer? The one that uses 2 dp or the one that uses the root 97?
The one that uses the root 97.
Super fantastic. And we've just gone over by a minute. Okie dokie, I'm just gonna close up the recording.